Okay, in the last segment, we talked about how to find the inverse transform of this function here, uh, which has a quadratic denominator that is factorable. Now, what if you had the same fraction, but there were a multiple of which is an exponential here? How would you handle that? Well, the answer is that that is exactly what we were talking about earlier with the unit step function. The inverse transform of cap f of s times e to the minus as is you take the inverse transform first, just as if this were not here, to get little f, and then you shift it on the t-axis by a units to the right. Notice in this case, this sign and the sign of a here are the same, so we won't need to worry about flipping from a minus to a plus. Okay, so what we would say first of all is that this is, let me just introduce some notation to save some writing. This is e to the minus 5t times cap f at s. And f at t, well, we did that just before. You split this with partial fractions, and it turns out that the inverse transform of this fraction without e to the minus 5t is 10 e to the t minus 4 e to the minus 4t. So the inverse Laplace transform of e to the minus 5t times that same fraction is this function shifted to the right by 5 units. So this is u t minus 5 times this function here, where you replace the t's by t minus 5. So there's our inverse transform when we've picked up this exponential here. Okay, now let's step this up a little bit by putting all the pieces together. This problem is actually going to involve a shift on the s-axis as well as a shift on the t-axis. Now, when I look down here, I notice first of all that I've got this e to the minus 2s. Well, that's going to take us back to this first shifting theorem, and so I'm expecting to work out the inverse transform back to f, little f, just ignoring that for the time being. And then once I do that, I'll introduce a shift on the t-axis. When I look at the rest of this, though, I see that the factors of 34 are 2 and 17, 1 and 34, of course, but neither one of those factorizations could give a middle term of minus 6s. Therefore, this one needs to have the square completed, and we'll take that as the first step, and then we will need to clean up the numerator a little bit as well. Okay, so minus 6 divided by 2 is minus 3. Square that, you get 9. So s squared minus 6s plus 9, that's s minus 3 squared. Now, I had to add 9 to get there, so I need to subtract a 9 on this. 34 minus 9 is 25 plus 5 squared. So we got a sum of squares down on the bottom. And now I've got 2 times s, but I'd like to write that in terms of s minus 3, so that the shift here and the shift here agree. Okay, well, if I write 2 times s minus 3, the 2s is good, but I am now subtracting 6, so I need to add 6 back in. 9 plus 6 is 15. and this whole thing is multiplied by e to the minus 2s. So a bit of algebra, but that's something we can handle. All right, now just look at this part here, neglecting the 15. Assuming now this were just s over s squared plus 5 squared, that would have inverse transform cosine of 5t. However, I've got a 2 here, and I have e to the minus 2s here. This e to the minus 2s means that I'm going to have to introduce a unit step function. And shift the cosine function as well. So that takes care of the 2, the s minus 3 over this. Now I need to do the 15 over this, and again take into account that this produces a shift on the t-axis. So let's get that part started while we're thinking about it. T minus 2. Then 15 over, well, s squared plus 5 squared, that would be sine of 5t. But the t now has been shifted by 2 due to this. And now we're almost done, but not quite. And the reason it's not quite done is we haven't yet taken into account this minus 3, this shifting on the s-axis. Remember, when we shift on the s-axis, that introduces a factor of e. If we shift s minus a on the s-axis, then we have e to the plus at coming up on the t-axis. And you notice that's not in here yet. So, actually, I left that gap there thinking I was going to put it here and here, but I didn't really leave enough room. So what I'm going to do is kind of squeeze here and say, right in there, I need to have another factor, and that factor is the one that comes from this s minus 3. So that needs to be e to the 3t plus 3t, goes right in there. And let me just write it out now in a reasonably coherent way. E to the 3t times the quantity 2 u t minus 2 cosine 5 t minus 2 plus u t minus 2 sine 5 t minus 2. And I suppose you could factor the ut minus 2 out in front here as well. But there it is. There's the inverse transform. And this one is pretty complex. We have a shift on the s-axis here. We have a shift on the t-axis coming from here. And then, of course, we have to complete the square and think of this as two fractions. So quite a bit going on here. But if you take it one piece at a time, it really is, it's pretty doable.